Okay, we're going to go on to the final problem. This is a distance problem where distance equals rate times time. A plane travels 870 miles against a headwind in 3 hours. So that plane is going against the wind and the wind is holding it back. Traveling with a tailwind, now the plane's going the other direction and the wind is now pushing it and helping it along. The plane travels 700 miles in 2 hours. Find the speed of the plane in still air and the speed of the wind. And again, we need our x and y, and we see it right there, the speed of the plane in still air and the speed of the wind. So let's write that down. My x is going to be the speed of the plane in still air. And my y will be the speed of the wind. Now we need to establish the speed that the plane is actually moving in the wind. So if it's moving at x and the speed of the wind is pushing it, or it has a tailwind, or we would say it's going with the wind, we would say that our rate of that plane is x plus y. But if it is in a headwind where the wind is pulling it back, or we're going against the wind, then we would say that is x minus y, the speed of the plane in still air minus the speed of the wind, which is pulling it back. Okay, now the problem tells us that when the plane is in the headwind, it takes 3 hours to go 870 miles. Now we're going to use our little equation, distance equals rate times time. So to get distance, we have to take the rate times the time. Well, the headwind rate is x minus y, and it takes 3 hours, so we multiply that. And that, we are told, the plane travels 870 miles. Now, with the wind, or the tailwind against the plane, we have x plus y. It takes 2 hours. So time times the rate, and that gives us 700 miles that it travels. So there's our two equations to solve. We do need to go ahead and distribute. And I'm going to use the addition method this time. I'm going to multiply the top equation by 2 and the bottom equation by 3. And as you can see, I'm going to be canceling y's. And I'm going to move it up here. I'm going to get 6x minus 6y, and then 870 times 2 is 1740. I'm going to multiply and get 6x plus 6y in the second equation, and 3 times 700 rather, is 2100. And so now I'm adding the two equations. My y's are going to cancel. I'm going to add my x's, and I will get 12x equals, and then add 1740 to 2100 and get 3840. And I will divide by 12, and I will get that x equals 320. Now what does that mean? Well, 320 miles per hour because x stood for the speed of the plane in still air. So it's 320 miles per hour for the plane. I do also need to establish what my speed of the wind is. So I would just take one of these equations. I think I'm just going to take this 2x plus 2y equals 700, and I'm going to plug in 320 for x. And when I multiply, I get 640 plus 2y equals 700. I'll subtract the 640 from both sides and get 2y equals 60, divide by 2, and my y equals 30, and that's the miles per hour for the wind. Now let's check this. I'm going to go and make some room here. When I check this, I'm going to use that distance equals rate times time formula. I'm going to say that if I was traveling with the wind, okay, I would add x plus y, so I would get 350 would be the rate, times the time with the wind. It said we went for 2 hours, and that should equal 700 miles, and it does. If I'm traveling against the wind, then I'm going to say 320 minus 30 and get 290 times it takes 3 hours, and does that equal to 870? And it does, and so my problem checks out. So once again, if you have any questions about any of these problems on section 5.4, please post them on the Blackboard discussion board so that everybody can see the answers, because I'm sure everyone's going to have questions.